This video is intended to help students as part of our flipped classroom. They should watch it prior to the day that we cover lesson 4.10. We are going to do a quick refresher first on the binomial theorem. So the binomial theorem states that if you have a binomial, a plus b to the n, that you can take n choose k, and then each of the terms will look like a to the n minus k and b to the k. So as a reminder, this funky symbol right here that kind of looks like an E means add up each of your terms. So this will end up looking like n choose 0, or if you want to write it as nc0, that's fine. A to the n, b to the 0. And then you'd have n choose 1, a to the n minus 1, b to the first. So in each of the terms, your power on your a is reducing and the power on the b is increasing, all the way until you would reach n choose n, a to the 0, b to the n. We're going to work through a couple problems from the book. So we're going to start on page 329 and work on number 2. The question says, consider the expression a plus b to the 12th power. And question A says, what is the coefficient of the a to the 5th, b to the 7th term? So a couple things that we can just talk about from the beginning. 7 plus 5 is giving us the 12, so that's good. And we have, in this case, 12 choose. You can use either 5, or you can do 12 choose 7. They should give you the same answer. So in this situation, 12 choose 7, or 12 choose 5 is 792. Question B says, what other terms are going to contain this same coefficient? Well, we would need the coefficient to be the same if the powers were 5 and 7. Well, we already have a to the 5th and b to the 7th, so that would mean that we would have a to the 7th, b to the 5th. Question C, which terms do not share their coefficients with any other terms? So when we're thinking about that 12th row of Pascal's triangle, if you remember in the triangle, the only way that something would not share a coefficient is if the entry was directly in the center of Pascal's triangle. Otherwise, the triangle itself is symmetric. And so if you get something over on the left, you're going to get something that matches it over on the right. So in this situation, to figure out which term would be directly in the center, well, half of 12 is 6. So you'd have 12 choose 6. That would be the coefficient. And the term that would go along with that would be a to the 6th, b to the 6th. In other words, if you flip-flop the powers like we did in part A and part B, you would still get a to the 6th, b to the 6th. So you wouldn't have any different terms that you would be talking about. Next, we're going to look at page 330. This is number 9. In the expansion of a plus b plus c plus d plus e to the 14th, what is the coefficient of the term a squared, b cubed, c technically to the first power, d to the 5th, e to the 3rd? So the first thing that I always like to do is make sure that if I add up all the powers that I would get, in this case 14. So 2 plus 3 is 5, plus 1 is 6, plus 5 is 11, plus 3 is 14. So yes, that checks out. That's great. And then the hard part about this is that we've never looked at something that has this many terms being added together. We've only looked at binomials, which have 2. So we have to kind of figure out what would the pattern be if we have more terms. So as you remember, when we do things like 12 choose 5 or 12 choose 7, the 12 came from the power on the binomial. So in this case, we have 14 as our power on the binomial. The amount that we're choosing in the earlier examples, when we chose 5, that was the power on the first term. So we would have 14 choose, in this case, 2. Now, in earlier examples, there was nothing that came after this. There wasn't something that we multiplied it by. But you could kind of think of maybe multiplying by some fancy form of 1. So if we take 12 minus 5, we would get 7. So we've got 7 still options, and we're going to choose 7 of them for that power. 7 choose 7 is 1. So in this situation, excuse me, in this situation, if we take 14 minus 2, we'll get 12. So there are 12 remaining options. 14 minus 2. And we are going to choose 3 of them for our next power. Then you'll continue to repeat. So take 12 minus 3. And we're going to choose the next power, which in this case is 1. So 9 choose 1. 9 minus 1 is 8. So there are 8 remaining. We're going to choose 5 of them because that's the next power. That's the power on the D. And then we've got 3 choose, in this case 3. That's the power on the E. So you're going to take 14 choose 2 times 12 choose 3 times 9 choose 1 times 8 choose 5 times 3 choose 3. So if you do that all together in your calculator, you should get, oh, it's huge. Whew. That's a large coefficient. The reason that we're multiplying each of these together is because we need the power, we need the A term and the B and the C and the D and the E. We need them all together. When we say and in mathematics, we multiply.